Hi, my name is Marina Fennell, and I am a graduate student at the University of California, Irvine, UCI, in the Earth System Science Department. My research question is how much carbon can the ocean take up? Ocean modeling in the time of climate change. So most people know that the atmosphere is filling up with excess carbon dioxide. But did you know that the ocean is too? The ocean acts like a giant sponge, sucking up carbon from the atmosphere and storing it away. Last year, in 2019, the ocean accounted for 23% of carbon uptake, while the atmosphere absorbed 49% and the land 28%, as you can see in this pie chart. In fact, since all the way back to 1750, the ocean has absorbed about a third of all carbon emissions, a third. Needless to say, the ocean is extremely important in the fight against climate change, but we need to know if it will keep sucking up carbon or if our ocean sponge is full. So to study how much carbon the ocean can take up, we must be able to measure how much carbon the ocean has in it already. But because the ocean is so vast, it is too large for scientists to measure every single part of it. Instead, we build ocean models that fill in the blank spots where research vessels have not taken measurements. On this map, the red lines show where research vessels have taken measurements, and the blue areas in between are the blank spots that ocean models help to fill in. One of the chemicals that scientists on these research vessels measure is called radiocarbon. We use radiocarbon to estimate the amount of carbon entering the Earth's oceans and the rate at which this happens. The radiocarbon that scientists measure in the ocean has two parts, the natural part and the unnatural part. The natural remains relatively constant through time, while the unnatural part is a direct result of the atomic weapons testing in the 1950s and 60s. This plot shows the amount of radiocarbon in the atmosphere. This dramatic increase is due to the so-called bomb spike. And the subsequent decrease is due to natural decay of this radioactive element, as well as natural uptake by the ocean and the land. In order to use radiocarbon in our ocean model, we must first separate the natural and the unnatural effects. Our first step is to model the natural radiocarbon signal to show how much carbon the ocean stored without the influence of humans. Then we'll model the total amount of radiocarbon. And once we subtract the natural from the total, this natural plus unnatural signal, we'll be left with just the unnatural signal. The separated radiocarbon signals will help our ocean model to estimate more precisely how much carbon the ocean sponge has absorbed. This is a completely new approach to separating the radiocarbon signals, and we are expecting to have a far better estimate than the studies that have done this before. Knowing this number helps us to understand how the climate might change in the future. Unlocking this separated radiocarbon signal is the key to understanding how much more carbon the ocean can absorb in our fight against climate change. Thank you.